Welcome to This Explainer. Today we're diving straight into the extreme, bizarre, and honestly, sometimes completely terrifying consequences of skipping sleep. I mean, think about it. We spend roughly a third of our entire lives totally unconscious. But why? Well, we're going to uncover exactly why our bodies absolutely demand sleep and what actually happens when we try to fight off that fundamental biological need. Let's kick things off with a pretty staggering number, 264. That is exactly how many hours a 17-year-old high school student named Randy Gardner managed to stay awake during a super famous experiment back in 1965. Guys, that is an unbelievable 11 solid days with literally zero shut-eye. No way I could do that. And over those 11 agonizing days, Gardner experienced this incredibly rapid cognitive decline. It really shows how the brain just frantically breaks down without its required maintenance. By just day 2, his eyes couldn't even focus, and he completely lost the ability to identify objects just by touching them. By day 3, he was moody, super uncoordinated, and by the time he finally reached the end of the experiment on day 11, he was dealing with severe paranoia, short-term memory loss, and get this, full-blown hallucinations. Now, thankfully, Randy actually recovered from his experiment without any long-term physical or psychological damage. But for a rare few people on this planet who carry a specific inherited genetic mutation, this terrifying inability to, enter the sanctuary of sleep, it's a fatal daily reality. It's a condition known as fatal familial insomnia. It literally traps the body in this permanent nightmarish state of wakefulness that just progressively worsens, ultimately leading to dementia and, tragically, death within just months or years. Okay, moving on to Section 1, the everyday epidemic, the hidden crisis in our society. Now, obviously, we aren't all staying awake for 11 days straight, but we are absolutely facing an everyday epidemic of sleeplessness. And the sheer scale of the problem is right here in our own backyards. In the US alone, a massive 66% of adolescents are chronically sleep-deprived. That is well over half of the teenage population simply not getting the rest their developing brains desperately need. And guess what? The crisis definitely doesn't stop with teenagers. Looking at the adult population, 30% of American adults are also regularly missing out on this absolute biological necessity. It's kind of crazy how normalized it is in our culture to just run on empty, right? But as we're about to see, the biological cost of that is incredibly steep. So the really crucial point here is understanding the baseline of what our bodies actually demand to function safely. Just to clear up any confusion, because you hear a lot of numbers thrown around, the science is actually very clear. Adults require 7 to 8 hours of sleep per night, and adolescents need about 10 full hours. Missing those nightly quotas isn't just some minor inconvenience you can shrug off with another cup of coffee. It actually acts as a trigger for serious bodily harm. It causes this whole cascade of dangerous symptoms. We're talking everything from impaired learning, memory, mood, and delayed reaction times all the way up to severe physical issues like high blood pressure, systemic inflammation, a way higher risk of diabetes and obesity, and yeah, like we saw with Randy, even hallucinations. To kind of humanize all this clinical data for a second, consider this really tragic case from 2014 involving a super devoted soccer fan. Basically, in an effort to watch the World Cup, he attempted this massive 48-hour waking marathon. Sadly, the physical toll was just way too much, and he ended up suffering a fatal stroke. Now, while staying awake for 48 solid hours is for sure an extreme case, studies actually confirm that chronically getting fewer than 6 hours of sleep a night multiplies your stroke risk by a terrifying 4.5 times. That's compared to someone sticking to a healthy 7 to 8 hour routine. The damage is cumulative, guys, and it is very, very real. All right, let's jump to Section 2, the buildup of brain waste. Unmasking the biological culprit. So we know sleep deprivation is dangerous, but why? What's actually happening in there? Well, think of your waking hours kind of like a car engine running. Your busy cells are constantly consuming your day's energy sources. And as they do that, they break them down into various chemical byproducts, which is essentially cellular exhaust. One of the main byproducts is this stuff called adenosine. And as adenosine builds up in your brain throughout the day, it drastically increases your urge to sleep, creating this intense, overwhelming biological feeling that scientists call sleep pressure. Oh, and as a quick, super interesting side note, especially for those of you sipping a coffee right now, this exactly explains why your morning brew actually works. Caffeine doesn't magically create energy out of thin air. Actually, it simply acts as a biological roadblock. It works by literally blocking adenosine's receptor pathways in your brain, basically hiding all that accumulated exhausting adenosine from your brain's natural receptors. Pretty cool, right? But as this really powerful quote from the scientific research shows, you just can't trick biology forever. The adenosine and all those other waste products, they are still there. And if they're not cleared away, they collectively overload the brain. This leads directly to all those negative symptoms of sleep deprivation we outlined just a few minutes ago. This brings us to Section 3, the nighttime cleanup crew, revealing the brain's hidden mechanism. Okay, so what exactly is this microscopic rescue operation that saves your brain every single night? Well, it all starts with a signal, triggered by the environmental darkness outside and the steady rise of those internal sleep-inducing chemicals like adenosine and melatonin. Your body starts prepping for maintenance. Your breathing slows right down, your heart rate drops, your muscles relax, and you slowly slip into a light doze that eventually deepens into non-REM sleep. The biological stage is officially set. And here is where the real hero of our story enters, the glymphatic system. Think of it as your own personal nightly maintenance crew. When you finally fall asleep, this incredibly cool cleanup mechanism becomes highly active. It literally uses cerebral spinal fluid to wash away all those toxic cellular byproducts, like the adenosine we were just talking about, that have been quietly accumulating between your brain cells all day long. It is genuinely like a highly coordinated physiological symphony happening inside your head. The glymphatic system flushes out the toxic adenosine. Meanwhile, these recently discovered lymphatic vessels serve as little pathways for immune cells to come in and help clear out the brain's daily waste. And at the exact same time, this deep non-REM sleep phase is allowing your body to repair its DNA and completely replenish its energy sources. But here's the catch. All of these absolutely vital restorative mechanisms rely entirely on you actually being asleep. So we're left with a pretty fundamental reality check here. Knowing that every single extra hour you stay awake is actively flooding your brain with toxic cellular exhaust. And knowing that skipping sleep literally means skipping the vital washing cycle that keeps you healthy and sane, you really have to ask yourself tonight, is staying awake really worth the cost?